Okay, Advanced Maths Trig Honors Mods 2, 3, and 4. It is Tuesday, April 14th. So as we've been doing, get out a piece of paper. Let's take a few notes on today's topic. Upper left corner, 4/14/20 is the date. The title says logs, so we're still dealing with logarithms. And it says logs and then arrow condense and expand. So we're going to condense logarithms, mean taking a logarithmic problem that looks fairly complex and trying to condense it and simplify it. And then we're going to take a logarithmic expression that doesn't look so long and complicated, and we're going to try to expand it and break it apart using three main rules for logarithms, okay? So you don't have to divide up your paper at all. We're just going to kind of go with the flow. If you need to flip over and continue on and use the next page of your notebook or the back of your paper, that's fine, like I'm going to do. Here we go. All right, again, Tuesday, April 14th. I'm going to have you put a star by our three main rules here. We've got a product rule for logarithms, a quotient rule for logarithms, and a power rule for logarithms. And depending on who you had for a teacher last year, this might or might not look familiar. I hope it looks familiar. But really, the three rules aren't that complicated. Here we go. The product rule for logarithms says the following. If I ever have the log, that could be a common log, natural log, regular log. It doesn't matter what the base is. If I have any logarithm, and it's the log of, now notice I use the letters m and n, m times n. It's the log of a product. You are allowed to change that, if need be, when solving an equation. And you'll see when we use these rules a lot in the next couple of days, the next 3 days, in fact. You can change the log of m times n into the log of m plus the log of n. Oh, so the log of a product turns into the sum of two separate logs. So the log of m times n equals the log of m plus the log of n. For example, what if I had a simple case like the log of 5w? Because the 5 is dot connected to the w, you are certainly allowed to split that into the log of 5 plus the log of w. That's all that says, okay? Well, put a star and go quotient rule. If we just used common sense here, remember we just said the log of a product equaled the sum of the two logs? I'll bet you that it makes perfect sense that what? The log of a quotient, the log of a m over n scenario, the log of a quotient is equal to probably what? The difference of the two logs. So the log of m over n can be split up into the log of m minus the log of n. Okay, that's called the quotient rule for logarithms. So the example I've got, log, notice I have a base of 8 this time. Again, the base is rather irrelevant. Log base 8 of 7 over x. Oh, it's the log of m over n. So I can change it into the log base 8 of 7 minus, and then write log base 8 of x. So the log of m over n can be changed into the log of m minus the log of n. That's the quotient rule. Finally, the last rule that we've got for logarithms, the third one, is called the power rule. And it simply says this. If I ever have a logarithm, again, the base is irrelevant. It can be any base that you want. If I ever have the log of m raised to the p power, oh, guess what? You're allowed to take that power and move it to the front of the logarithm and turn it into a dot-connected scenario. So anytime you have the log of something that's raised to an exponent, that power, that exponent, can get moved to the front of the problem. So the log of m to the p power can be written as p times the log of m. Just put the power out in front. So the example written here, example says log base 3 of 5 to the 4th. I am allowed to take that exponent, that power, and move the power out in front. That's why it's called the power rule. So if I move the power in front, this would be what? 4 times the log base 3 of 5. Okay? Now, at first glance, you're thinking, well, what's the point? Why would we ever use those rules? You will really see tremendous use for those rules when solving exponential, logarithmic growth and decay equations the next few days. So these rules, even though they appear simple, have to be memorized and have to be properly utilized, okay? Now, all they do on this day of notes to get you to practice those rules and to learn them and work with them and understand them is what's called expanding and condensing logarithmic problems. So, first thing we're going to do, go ahead and write in your notes the directions, expand each. And it's almost like I've got a problem here written in logarithmic form that I want you to expand. It's almost like it's an engine that you're going to take apart and have it end up in as many pieces as you can. Okay? So let's take a look at number 1 here. Guys, focus with me here. Don't just look and copy and have the goal of copying your notes as fast as you can and being done. If you don't really think and follow along with me, you're going to be in trouble when you try these on your own. So here we go. Okay. My advice is look at the problem and describe what you see. It says ln of y times radical x. That's just a logarithmic. In this case, ln, remember, is a natural log. I've got a natural log. Oh, and it's y times the square root of x. There is a dot in there. So isn't this the log of m times n? It's a product. So if I go and use the product rule, which says take the log of m times n and make it the log of m plus the log of n, this is really going to be the log of y plus the log of radical x. Now watch what I do. Instead of writing radical x, isn't the square root of x really x to the 1/2 power? Remember, we discussed that yesterday, that a square root box is really a 1/2 power. And you're thinking, well, why would I do that? Oh, because that square root box is really a 1/2 power. Even though I successfully applied the product rule here and turned it into ln of y plus the ln of radical x, this power can now get placed in front of this ln here and follow the the power rule. So expanding this even one step further, I end up with ln of y plus, move the power out in front, 1/2 ln of x. That's what I mean by expanding your logarithmic problem. And really, we used the product rule, then we got to use the power rule. And these expansions and on the back condensed problems that we're going to do allow us to really learn and manipulate problems to learn our rules. Okay? Look at number 2. It says the log of quantity a squared radical a minus 1. Well, once again, do you agree that there is a dot connection between the a squared and the radical a minus 1? So I've got the log of what? Something times something. So utilizing the product rule, this is really the log of a squared plus the log of, now it says radical a minus 1, doesn't it? Isn't that really a minus 1, again, to the 1/2 power? So notice I can go one more step, can I? Because I've got a power involved here and a power involved here. So putting the power in front of the logs, I would have 2 log a plus, and then move that power in front, 1/2 log of a minus 1. Okay, whoops, there you go. Can you see that? That gives me the final answer on that problem. I've expanded that one. Third one, it says ln of the cube root of x over y squared. Okay, now careful here. Even though we see a quotient, right? Remember the log of m over n would be the log of m minus the log of n? There is a cube root box above this whole thing. So technically, my first step is to write the ln of x over y squared, and that whole thing is raised to the 1/3 power because it's under a cube root box. Agreed? And then that 1/3 can get placed in front because it's a power. Oh, so we have 1/3 in front of the ln of x over y squared. Agreed? Now, I'm not done yet. That 1/3 is just a constant dot connected in front of the ln, so I'm going to ignore it for a second, pretend it's not there. Guys, isn't this the ln of m over n? This is a quotient rule problem, isn't it? So when I rewrite that, now notice there is a 1/3 in front of everything I'm about to write. So I'm going to put 1/3, and I'm just going to kind of put a bracket, because inside the bracket is what I get when I expand the ln of m over n here. So I've got the ln of x minus, now, technically I would write the ln of y squared, but do you agree that the squared, the exponent, would get moved in front because it's a power? So it's really 2 ln of y. And then this 1/3 that's dot connected to that entire quantity can get distributed to each. So technically, guys, my final expansion would be 1/3 ln of x minus, now when I take 1/3 times 2, that's 2/3 ln of y. Did it. Okay? And then number 4 there, I notice it's the ln of something over something else. So I notice that's a quotient, correct? So I'm going to write ln x minus ln of, okay, here we go again. Isn't that a square root box? So that's really x squared plus 1 to the 1/2 power. And then that power can get placed in front of that ln. So I've got ln of x minus 1/2 ln of x squared plus 1. And I rewrote my logarithm and expanded it. Okay, so we'll do some of this when we solve logarithmic and exponential and growth and decay equations. And you'll be shocked how much you use this when you use integration techniques in calculus next year. All right, I'm going to flip to the back. The 5th and final expansion problem. Oh boy, I've got log base w of radical x times y to the 4th all over z to the 6th. Looks crazy. Okay, guys, don't panic. When you decide what to do first here, obviously, I've got something up here that's over top of something down below. So that is an m over n quotient rule problem. Right now, if I covered up what was on top and bottom, we do see a fraction bar, right? So my first thought in my expansion is to go ahead and write the log of radical xy to the 4th minus the log of z to the 6th. Because it was a quotient bar, I put the log of m minus the log of n. Agreed? Now, notice this first logarithm. There's a dot connection between the radical x and the y to the 4th. So because that's a dot connection, that's the log of a product, isn't it? So I'm going to make that the log of radical x, which is really x to the 1/2, plus the log of y to the 4th, right? Because remember the rule? The log of m times n equals the log of m plus the log of n. minus, and then I still have sitting there the log of z to the 6th. And then that exponent goes to the front. This power goes to the front. This power goes to the front. So it looks like my final answer is going to be 1/2 log of x plus 4 log y minus 6 log z. Wow. And that is me expanding that initial logarithm question. Okay? So log w radical x y to the 4th over z to the 6th ends up getting expanded and looking like that. They both mean the same thing. Condensing is just working backwards. Here I'm looking at an engine that's already been taken apart, and I'm going to put it back together and see what the original engine looked like. So guys, think about it. Does everybody agree? Look at this first problem. Log base 4 of w minus 2 log base 4 of y. If there is a 2 out in front of this log, do you agree that if it's out in front that it must have been an exponent to begin with? Oh, so I'm kind of piecing this back together and working backwards. So this is really log base 4 of w minus log base 4 of y to the 2nd. Agreed? Oh, and now look, it's the log of w minus the log of y squared. Remember when I had a quotient, it turned in to a subtraction problem? And since we're working backwards and condensing, I'm now going to take the subtraction problem and condense it back into a quotient. Because this is really the log of m minus the log of n. So it's going to be the log, notice base 4, of what? W over y squared. Ah, so the engine that was taken apart, I put back together and got that answer right there. Okay, that's condensing a logarithm using our logarithm rules. Go to the next one. Now careful here. Notice there's a 1/3 in front of this log base 3 of 7x. So does everybody agree that if there's a 1/3 in front, again, it must have been an exponent, not over top of just the x, but the whole thing must have been raised to that power, right? Because it's now out in front, as you see in this problem. So technically, I've got log base 3 of 7x, and that 7x is raised to the 1/3 power. Okay, now, because each of these are raised to that power, oh, and there's a dot connection in here, that 1/3 technically goes with the 7 and goes with the x both. So in other words, they were both under a cube root box. Agreed? So technically, this is the log base 3 of the cube root of 7 times the cube root of x. Does that make sense? Again, the 1/3 became a power. Now that it's up there above both of these, they're each raised to that power. But since a 1/3 power is a cube root box, this is really log base 3 of the cube root of 7 times the cube root of x. Oh, and that, I guess technically, we could write as log base 3 of 1 cube root box and just leave the 7 and x inside there. I could have just left it like that from the start. Everybody agree? So that one I made a little more complicated than we needed to. I gave you the extra step of individualizing the cube root box. Technically, when I looked right here, I should have realized, oh, that's a cube root box over top of this whole thing, and just turned it into that in its condensed form. Okay? Next one, ln x plus 3 ln of x plus 1. I look at that problem, you look at that problem, and the first thing you should notice is the 3 that's in front of this natural log. This 3 that's in front, if it's in front, it must have been an exponent to begin with, agreed? So it now moves up as an exponent. And then what's the rule when you see a plus sign? Since it's the log of m plus the log of n, I would change it into the log of m times n. So it's really ln of x times x plus 1 to the third. So no big deal. We moved the power up top where it belonged. And because there was a plus in the middle, we made it a dot-connected group. And we condensed it into that answer. Number 4. Okay. The old rule, do what's in parentheses first, or in this case, do what's in brackets first. Now I'm going to leave that minus alone for a second and leave it as a minus. This 2 can get distributed to each of those, agreed? So if this 2 gets in front of that ln, and this 2 gets distributed in front of this ln, if it's in front of that ln, it really must have been an exponent here. And if there's a 2 in front of that ln, it must have really been an exponent here. So guys, do we agree that step number 1 on this problem, once that 2 gets distributed and becomes dot connected in front of the ln's, it really must have been an exponent attached to each. So I'm going to write ln of x minus, and then in this group, I'm going to have what after that minus sign? The ln of x plus 2 squared plus the ln of x minus 2 squared. Okay? Now look inside that bracket again. That is a plus sign. Oh, so I have the ln of m plus the ln of n. So this is really ln of x minus, and then the ln of what? X plus 2 squared times x minus 2 squared. And now, because there's a minus in the middle, dummy me, I'm running out of room, so I'm going to go way down here. I have the ln of m minus the ln of n. This is really the ln of what? M over n. So it would be x over, and then x plus 2 squared times x minus 2 squared. And I condensed that back into just one ln. Notice as I get these answers, it's just one log, one log, one log, one log on this one. So when you condense, you want there to be just one log at the end if possible. Finally, look at number 5 here. Using the same theory or thinking on that last problem, do you agree this 1/3 gets distributed and gets distributed? So this would be 1/3 ln y plus 2/3 ln of y plus 4. That's all in a bracket now, and then minus ln of y minus 1. So far, so good? Since this is dot connected to a logarithm, this must have been a power. This must have been a power. So I've really got ln of y to the 1/3, which is really the cube root of y, agreed? Plus ln of y plus 4 to the 2/3 power. And because that whole bracketed scenario has a plus in the middle, I have the ln of m plus the ln of n, which is the ln of cube root of y times y plus 4 to the 2/3. And that's dot connected because I turned ln of m plus ln of n into the ln of m times n. Oh, but then there's a minus ln of y minus 1. And anytime I see a subtraction and have the ln of m minus the ln of n, I'm going to make it a quotient, follow the quotient rule, and go ln of cube root of y times y plus 4 to the 2/3 all over, wow, y minus 1. And I end up with 1 ln, like I just said would be your goal. Okay, guys, now that's not easy. You got to really focus and go one step at a time. That's a lot for one day, I realize. I apologize that took so long, about 25 minutes, but we had to get expansion and condensing covered, or else you're not going to be able to solve your equations the next few days. So thanks for bearing with me. You're going to practice that. If you get stuck or you're still not sure, my problems mimic yours. You can always go back and re-watch one of these or more of them if you have to make sure you understand how to do that problem or those problems, okay? Homework looks like this. Again, Advanced Math Honors, today is the 14th. Your homework or your assignment for the day are these these 8 problems. I'm giving you 4 where you're supposed to expand, okay? And these 4 where you're supposed to combine and condense. So these 8 problems, 4 where you're going to expand and 4 where you're going to condense. These are due by noon on Tuesday, April 15th. Give it a shot. Try to expand the first 4, condense the bottom 4. So hit pause here if you need to. Get all 8 problems copied down onto where you're going to do them. Shoot me a picture of those by tomorrow at noon. Good luck. It's not going to be easy. Focus on your rules one step at a time. Okay? Thanks. See you tomorrow.